Hey, another good wave problem. So pause the video and read the question. Okay, I hope you've done that. So part A, we want to figure out how fast the waves are traveling. We're looking for the wave speed, how fast the energy is traveling in the waves. Remember, in transverse waves, particles don't actually move left and right. Energy moves left and right. The particles move up and down. So our wave speed is lambda f. We'll have to figure out lambda and f. We're told it takes 2.5 seconds for the boat to go up and down from its highest point to its lowest. So a period is going down and then back up again. The 2.5 seconds was just from the top to the bottom. So if we're looking at the wave here, so the time it takes this point here to come all the way down was 2.5 seconds. So it'd be 5 seconds total to go up and down. We call that the period. Period is the amount of time it takes to go through one complete cycle. Remember that period is 1 over the frequency, or frequency is 1 over the period. We were told that the wave crests are 8 meters apart. So from one crest to the next, if we're looking in space here, so if this were my x-axis and this were my y-axis going up and down, we're watching a snapshot. So time is frozen here and we're looking at a few crests of the wave. Then the wavelength is the distance, the physical distance in x from one crest to the next. And we're told that that was 8 meters. So lambda is 8. Period was 5. So F is 1 over 5. So we get V equals 1.6 meters per second. Part B, the amplitude is the distance from the midline up to the top. The problem tells us that it's 0.62 meters from top to bottom. That's 2 amplitudes. So the amplitude is only half of that, 0.31 meters. And part C says, well, what if we change the amplitude? How will that change everything else? So if instead the total distance here were 0.30 meters, 30 centimeters, then the new amplitude would be half of that, 0.15 meters. Wave speed, however, this part would not change. Velocity does not depend on the amplitude.